Well, today I thought we'd have a look at some test signal generators. One of the most important one is the PLUGE, that's Picture Lineup Generation Equipment. It's a BBC acronym. Now, this is used to set up the brightness and the contrast of your picture monitor on which you are trying to make a engineering assessment of the picture, and in order to achieve a measurement like that, your picture monitor has to be set up correctly. So the first step is to turn the PLUGE generator on, and the switch is over there. At which point the PLUGE waveform appears on all the monitors. Now it has a number of sections, and we'll show the oscillogram of these sections as well, so that you'll see how that joins together. So the most obvious point is the white patch, and the idea is that you set your white patch to be the same on all the monitors. There's a grey patch which encourages you to believe that the thing is relatively linear, and there's also here two very small vertical lines. Now I'm going to maladjust the monitor so that you can see that. And if I turn the brightness up and the contrast up badly, a bit of LF distortion there, but you can see here that there's a black bar and a white bar. And the object of the exercise is to set it so you can't see the black bar and you can just see the white bar. And in order to make that adjustment, I'm going to go to engineering lighting. At the moment the lights are on here, the working lights, but operationally it would be like this. So the first step is to turn the brightness and the contrast to a sensible level. So I've reset the contrast so they all match, and here, I hope you can make this out, you can see the black bar and the white bar, and the idea is to adjust it just so you can't see the black bar and you can see the white bar, so that now you know that the light output of the tube is 0 at correct black level. Ta-da! This white level, these days you would set that with a spot meter, but back in 1963 you didn't have spot meters, you just had your eyes, so the object would be to make all the picture monitors to look the same. And this gives you confidence that when you're exposing your camera and adjusting the camera's black level, that you make the right decision. One of the few test signals available back in 1963 was Sawtooth. Previous generation of vans didn't have proper test signals generators installed, but MCR21, as well as the PLUGE which we've been looking at, has got a Sawtooth generator, and this Sawtooth can be used for checking amplitude and the linearity of an amplifier, say. And on the scope here, now you can see the peak there, which represents peak white, black level, and the bottom of the sync pulse, and of course the linearity of the rising Sawtooth is an indication that the amplifiers and the circuits that it's passing through are still linear. Here's the picture on the picture monitor, white and black. Not very exciting, but a fairly straightforward generator which was easy to make. So this is the Sawtooth generator that we're using. It's not exactly the correct one, it's very similar. It has controls on it for adjusting the sync amplitude, the amplitude of the Sawtooth, and the Sawtooth's black level. Above it and to the right is the PLUGE generator, which we've also been describing. It has no controls on it at all and is self-contained and set up. This is a 625 model. There is also a 405 model which is identical in appearance but just has different value components, and the vehicle would have the appropriate one plugged in. Another test signal installed again for the first time in an outside broadcast van is pulse and bar. The original unit installed, BBC designed and made by Gresham Lyons, was a valve unit, and alas we haven't been able to find one, so we've taken the next best choice, which is a Marconi unit. It's solid state, but I'll forgive it for that because it works, and here it is, and the pulse and bar waveform is used as an signal to send externally. It doesn't appear within the vehicle anywhere for testing. It can only be sent to line for the line testing wherever it might go, through BT or through a radio link. Now we're going to have a look at the waveform on the oscilloscope, which means changing position. Right, so here's the scope. We've looped our vehicle output back in so that we can see it on the scope. It sounds a daft way of doing it, but as I said, this test signal, the pulse and bar, was only ever meant to go to line. So for the purposes of explaining it, we've looped it back in on the input to DA3, and here's the output of DA3. And simplistically, there is a pulse and a bar. And on the picture monitor here, you can clearly see the pulse and the bar. The bar has got the negative pulse in it, which is gives you the ability to look at the distortions at white level as well as black level. Now, how pulse and bar works is that if I expand the trace, and there'll be a bit of a delay here while I desperately twiddle at the knobs to try and make it do what I want it to do. Horizontal shift, there we are, a bit more expansion, and we'll have the intensity up to 4. That's all you get. I hope you can see that, but that is the expansion of the pulse. And if I take this screwdriver as a pointer here, you can see the waveform goes up to the sine squared pulse and bar shape under the coggle at the bottom. And really it's that coggle that you're interested in, because depending on the quality of the circuit involved, it will be a small coggle or a bigger coggle. And there's a graticle, an oscilloscope graticle you can put in, and there's a K rating factor that comes out of this, and you can say that it's got a particular performance. So I'll just go along. Oh, this scope's not up to it. The bar is off here. That's got it. Can I magnify that anymore? Possibly not. That's all you get, but that's the inverse pulse that I pointed to on the picture monitor, and you can see the coggle there is at the top, and it's a similar degree of distortion as there was at that level. So simplistically, that's pulse and bar waveform. There are reams of information available on this. I would particularly recommend a book written by Weaver, who was a very clever man. Depressingly clever, because he's so much brighter than the rest of it. The chap was, in my view, was a genius, and his work in describing these test signals is really well worth reading. So here are the books that I mentioned by L.E. Weaver, and this is a Marconi publication. This one is an IEE monograph, and the treatment is very thorough. And inside we can see here the sine squared pulse and bar signal, and the description relating to it, the T pulse, with, as we had, a bit of a wriggle on the end. And the T pulse, incidentally, had typically a 1T pulse or 2T pulse, the 1T being a 10 meg bandwidth and the 2T being for 5 megs bandwidth. And the book goes on to explain it in detail. And there's the K rating that I spoke about, and here's the graticule shape which your pulse should live in for particular K rating measurements, and it goes on and explores it in full and proper detail. And if anybody who is interested in this sort of thing, I can really recommend getting hold of some of his works. Oh, where did that come from? Ah, because it's stupid, it's that one. Oh, it's gone hummy. Why has it gone hummy? Vehicle within the vehicle. So this is DA3 here, an ordinary BBC distribution amplifier of the period with 3 outputs. It's an AM4/511. Not hummy. So DA2 is unhappy. Let's try DA3. Looks better up there. Yeah. So DA2 wants to go in the fault book.
That's 2 things there, isn't it? Do you remember what the other one was?
The sync pulse generator.
Which we've now fixed though, sorry.
Well, we haven't fixed, we've bodged it. I've been there professionally. Sync pulse missing on Songs of Praise. And there was a great deal of shouting and wailing because pressing the SPG changeover unit didn't fix it. And that turned out to be a faulty BNC connector on the back of the sync pulse generator changeover unit. And we fixed that with 20 minutes to go. But there we are, broadcasting's like that. Anyway, back to this.